Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aliani Batrisha binti Ahmad Mahiri with number ID SA22124. Today I will introduce about San Bruno pipeline explosion. What the cause of San Bruno pipeline explosion? On September 9, 2010 at around 6:11 p.m., a 30-inch diameter pipe of line 132, an interstate natural gas transmission pipeline owned and operated by the Pacific Gas and Electric Company was ruptured in a residential area of San Bruno, California. The breach created a crater approximately 72 feet long and 26 feet wide. The line cracked, releasing the natural gas, which it ignited and resulting the fire that destroyed 38 homes and damaged 70. The National Transportation Safety Board determined that the Pacific Gas and Electric Company deficient quality assurance and quality control during its Line 102 relocation project in 1956 was the most likely cause of the accident. Other cause is inadequate pipeline integrity management program, which is failed to detect and repair or remove the pipe section. So in the next slide, we can know about the type of corrosion, the prevention for the explosion, and the human manufacturing, and the uh, similar case with the San Bruno pipeline explosion.
Hello, my name is Harni Poking, ID number SA22009. I am going to talk about the mechanism of corrosion and the type of corrosion that happened in this case study. Corrosion is a deterioration of a metal surface caused by chemical attack by its environment. For corrosion to happen, water and oxygen must exist. What happens in corrosion is that the surface is oxidized. Corrosion happens because metal has an unstable electronic configuration with free electron within its structure. It will undergo corrosion to go back to a lower energy state, which are more stable. The type of corrosion that happened in the case study is crevice corrosion. Crevice corrosion occurred in places covered by deposits where there is limited access to the surrounding environment. It is an attack of a metal surface by a stagnant solution that exists between these small spaces. It is also an electrochemical or oxidation redox process. It is often occurred in bolted and riveted connection, gaskets and clamp. In this case study, it is between the pipeline. As the solution is stagnant, the oxygen depleted. At the cathode, the oxygen reacts with water to produce 4 hydroxide ion. This triggers a surplus of positive metal ions within the crevice, turning the interior of the crevice into an anodic node. The negative ion, or usually chlorine ion, migrate to the crevice, and further enhancing acid creation and attacking the metal more.
Okay, now we'll move on to the flow of incident. The pipeline named Line 132 was installed in 1956 and had a defective seam weld. What is a seam weld? A seam weld is a type of weld that runs along the length of a pipe or vessel, joining two edges or a flat metal sheet that has been rolled into a cylindrical shape, which means two metal sheets are being rolled into cylindrical shape, and to attach these two cylindrical shapes, seam welding is used in between them. That is what seam welding means. But in pipelines cases, um, longitudinal seam welds are common, meaning the weld runs parallel to the pipe's axis, which means not like this, they are attached like this, and the welding will be on top and parallel to the pipe. They are critical for maintaining the pipe's structural integrity, and they must also withstand the same pressures and stresses as the base metal of the pipe. So done with the meaning of seam. Now moving on to the flow incident bag. On September 9th of 2010, a power failure at the Millipeter's terminal caused a pressure increase in the pipeline. The defective seam weld had incomplete fusion and a partially welded section. These defects reduced the pipe's ability to withstand longitudinal stresses. So, when the pressure increased due to the power failure at the millimeter's terminal, the stresses concentrated at the defective weld. Hence, the weld failed, initiating a rupture that quickly propagated along the length of the pipe. And then, the natural gas began escaping from the ruptured pipe at a very high rate, in a very high pressure. And then, what happened was ignition. The released gas ignited, causing a massive explosion and fire. This explosion created a crater, destroyed homes, and tragically led to loss of life and numerous injuries. Okay, so next, our group has also done researches on some similar cases related to our topic, which is the San Bruno pipeline explosion. We have five examples here, such as the New Mexico pipeline explosion in 2000, and New Jersey natural gas explosion in 1994, Washington gasoline pipeline explosion in 1999, Belgium gas pipeline explosion in 2004, and finally the China oil pipeline explosion in 2013. Now we'll see the similarities of these five cases on how and why are they similar to the San Bruno incident. We have extracted informations and divided them into three factors um, to analyze the similarities. One is the similarity, the first one. The second one would be why did the failure occur, which is also the failure mode, and finally the material degradation. This first slide shows the similarity for New Mexico pipeline explosion and the New Jersey natural gas explosion. The second slide shows the similarities for Washington gasoline pipeline explosion and also the Belgium gas pipeline explosion. And finally, the very last case, which is the China oil pipeline explosion.
Assalamualaikum, my name is Yabatusha Badizaru Amri and my ID number is SA22036. So I'm going to be talking about the suggestion of prevention of corrosion, and in our case is the pipeline. So first of all, there is the cathodic protection. So this involves the application of a direct electric current to the pipeline, causing it to become the cathode in the electrochemical cells. So because of this, it reduces the corrosion rate by supplying electron to the metal surface, effectively protecting it from corrosion. Next is the coating. So what does coating do? Coating provides a protective barrier between the metal surface of the pipeline and the surrounding environment, preventing corrosive substances for coming into contact with the metal. So when coating can be applied to pipeline depending on factors such as the operating environment and the corrosion expected. So there's three types of coating. First of all, there's the metallic coating, and the example of this coating could be zinc. And next we have the inorganic coating, which could be epoxy, and lastly there's the organic coating, which could be polyethylene. Next is the material selection. So selecting material for pipeline construction that are resistant to corrosion, such as corrosion-resistant alloy or non-metallic material, can help minimize the risk of corrosion-related issue over the long term. So you need to choose the correct material, and this also depends on the environment. For example, for reducing environment, use nickel or copper alloy, but when it is an oxidizing environment, use chromium based alloys. Next, by controlling the environment is also one of the way we can prevent corrosion from happening in the pipeline. This is because when we control the environment such as temperature, humidity, and exposure to corrosive substance can help reduce and prevent corrosion. For example, if you reduce the temperature, it can reduce the reaction rate, and if you decrease the velocity of fluid, it can reduce erosion corrosion. And by removing oxygen from fluid, this reduces corrosion, And when you reduce ion concentration, it decreases corrosion rate. And lastly, when you add inhibitor, it acts as a retarding catalyst, which also helps reduces corrosion. Next, I'll be talking about the other factors that could have caused the pipeline to burst other than corrosion. So first of all, we have the human errors. So what could be the human error that could have caused this is when the errors made during the pipeline design, construction, operation, or maintenance could have an impact. This could involve making poor decisions, staff member not receiving enough training, or they just forgot to follow any protocols that have been set by the management. Next, we have the maintenance mistake. So per maintenance procedures such as skipping routine inspection, putting off needed repairs or replacement, or paying too little attention to well-known problems such as corrosion. So neglecting the correct procedure of maintenance could have caused the pipeline to burst. Thirdly, what could have caused the pipeline to burst could be these external factors. So the pipeline explosion may have been caused by sabotage, natural disaster like landslide or earthquake, or third-party damage such as excavation operation, meaning that during the construction or anything nearby that could have caused them to dig up the ground, this could cause some destruction toward the pipeline. Lastly, what could have caused the pipeline to burst other than corrosion could have been the material degradation. So, in addition to corrosion, the pipeline structure may have been weakened and failed as a result of material degradation brought on by wear, tear, erosion, or chemical reaction. And this affects the pipeline in long term, so it takes time for this to happen. But once it happened, the pipeline could have burst, as what happened in the tragedy. So that is it for me, and I'll be passing the presentation to the next presenter. Thank you.